sine graph, we only care about the y values on the unit circle, correct? Now this is going to be the hard part to wrap your head around. The y values of the unit circle are the answers to sine, and they're the y values on the graph of sine. Okay? The x values on the unit circle are actually the y values of cos, because they're the answers. So if I went cos of 30, so this, listening, if I went cos of 30, don't write this, I'm just explaining how this works. What would you tell me the answer is?
3/2.
Right. What's always in this bracket? X or Y? What's always in the bracket? X, and what's this? Your Y. So that's the coordinate on the cos graph. At 30x, my y is going to be √3/2. So yes, it's an x on the unit circle, but it's actually a y value on the graph. Okay, that's for cos. But we're not going to do cos first, we're going to do sine first. So we're going to draw the sine graph first. We're going to start at 0 degrees. I guess 0 radians. Now, before we actually start there, I want to teach you how to label an x-axis if it's in radians. If it's in degrees, you'd be like 360 divided by 6 lines, and you just draw your degrees. If it's in radians, it's a little bit more confusing, but it's not hard. So you just need to pay attention now so that it makes sense. Okay, paying attention? So, if we want to know what to label our x-axis in, we go and look for pi. Everyone paying attention? If we want to label our x-axis, you and Talon were distracted. We're going to go look at the pi. Do we see where the pi is? And we're going to count how many ticks it takes us to get to pi from 0. So this would be 1, 2, 3, 4, 5, 6 ticks. We agree? So each of those ticks is 6 ticks to pi. We agree? So what are we cutting pi up into? How many pieces? 6. So if this is 0, this would be 0 pi over 6. This would be 1 pi over 6. This would be 2 pi over 6. But how can I rewrite 2 pi over 6? Just pi over 3, right? This would be 3 pi over 6, which is just pi over 2. We agree? This is 4 pi over 6, which is just 2 pi over 3, actually. Then this is 5 pi over 6. Then this is 6 pi over 6, but that's just pi. And what would this one be? 7 pi over 6. Then 8 pi over 6, but what's that? 4 pi over 3. Then this would be 9 pi over 6, which is 3 pi over 2. This would be 10 pi over 6, which is actually 5 pi over 3. Then this would be 11 pi over 6, which is reduced. Then this would be 12 pi over 6, which is 2 pi. So do you see how they're all labeled? They're literally just pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. If it was 8 ticks to get to pi, we would do 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8. And you know you were right, because once you hit pi, you would get 8 pi over 8, which is pi. Then you keep going, 9 pi, 10, 11, 12. Okay? So if I want to label these without the ticks, this is pi over 6, pi over 3, pi over 2, so I'm going to underline them. Pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. All of those are on your unit circle. We agree? Those are all radian measures on your unit circle. So I want sine theta of 0. So I want sine of 0. What is sine of 0? What is my y at 0? 0. So my new coordinate is 0, 0. What does my sine max out at? What does it min out at? So I can label this 1. I can label this 0.5. I can label this negative 0.5. And I can label this negative 1. So I have sine of 0. The next one I have to do is pi over 6. What is sine of pi over 6? 1/2. So now I'm going to plot the point, pi over 6 and 0.5. So now I'm here. Then my next one is pi over 3. Then I'm going to do sine of pi over 3. And what's that? That's 3 over 2. And if I turn that to a decimal, it's 0.866. So this would be 0.75. Be 0.25. So it's at 0.866, so it's like here-ish. My next one is pi over 2. What is sine of pi over 2? 1. So now I'm at pi over 2 and 1. And then I'm going to come back down again. Because what did I do? I went to pi over 3. And then I went to pi over 6. So sine at pi over 3 was 1/2, right? Sine at pi over 6 was √3 over 2. Sine at 1, or at 0, is, or at pi over 2 is 1. Like it's just doing the y heights, right? Okay, then my next one is 2 pi over 3. What is sine of 2 pi over 3? √3 over 2. So we're back down to 0.866 again. Then I do 5 pi over 6. Yeah, sine of 5 pi over 6 is 1/2. Or 0.5. So we're back down to here. So far our graph is doing this. And it rounds, it doesn't make like a peak, like a mountain, it rounds like a hill. And then you go back down to pi. Sine of pi is what? No. What's y at pi? Sine of pi is 0. Then we start going below the x-axis. Why? Because our y values are going to be negative, right? So our next one is 7 pi over 6. What is sine of 7 pi over 6? Sorry? Yeah, negative 0.5. So I go to 7 pi over 6 and I go down to negative 1/2. And then I do 4 pi over 3. And sine of 4 pi over 3 is negative √3 over 2, which is negative 0.866 something, so it's here. Then I get 3 pi over 2. So sine of 3 pi over 2 is negative 1. Then I get 5 pi over, wow, that's messy. 5 pi over 3. 5 pi over 3. And then it's sine 5 pi over 3. Which equals negative √3 over 2. Then I get 11 pi over 6. Which is sine 11 pi over 6. Which is negative 0.5. And then this one goes back to 0. Now that's one unit circle. That's one unit circle. What happens after that? It's going to keep doing the exact same thing over and over and over because you're just going to keep hitting the same values because they're coterminal with it, right? So your sine graph does this to 2 pi, and then what's it going to do again? Where's it going to end at now? 2 pi more, which is 4 pi, then 6 pi, then 8 pi, right? And we just keep going. What about this way? Can it go this way? Yep. Because we can have negative radian measure, right? It's just going to keep going. It's periodic. It does the same thing over and over and over. So how long did it take to repeat itself? 2 pi. It takes 2 pi to repeat itself because if I start at 0, I go past a max, past a min, back up to 0, and then what happens after 2 pi? Just a stamped version. I could just do a stamp and a stamp and a stamp of the sine, and it would just keep going, right? So here it says, period, the length of the interval of the domain over which the graph repeats itself. So a basic sine graph, so a sine theta graph, a y equals sine theta graph, has a period of 2 pi or what? 360 degrees. This x-axis happens to be in radians, so I have to do it in radians. But if it was in degrees, I would do it in degrees, and I get the exact same graph, right? Because every radian measure has a degree measure that goes with it. Amplitude. Amplitude is half the, it should say vertical difference. We'll say vertical. I don't know why I just did that. Half the vertical difference between the max and min values of a periodic function. So, you can also use the formula, the absolute value of max minus min divided by 2. It's an absolute value because, something to note, amplitude is always positive. It's always positive. So how far is this one from the min to the max? What's the distance from the min to the max? 2. So the distance from the min to the max is 2, and the amplitude is half of that. So it's 1. So if we go max to min, distance equals 2, the amplitude equals 2 divided by 2, which is 1. It's half of that distance. Now, if you're like, I don't like that. I don't want to count from min to max, because I could go, okay, it's 1, 2, amplitude is 1. It's half of it. So if I count down 1 and I count up 1, they should reach the same spot, correct? So if I count my amplitude down 1, my amplitude up 1, they should meet at the same line. And I'm going to draw this line because this line is going to help us in a second. So they should meet at that same line. Okay? So, say I don't want to count up and down. Your amplitude, you can use the formula. It's max minus min divided by 2. And we don't want to use amp unless it's our notes. If it's written response or on a test, we write amplitude, because amp is actually a measurement, a unit measurement in like physics. Okay, or like light bulbs. So amp equals, we would write amplitude on a test. Our maximum, what was our maximum? 1 minus, what was our minimum? Negative 1, absolute value divided by 2. What's 1 minus a minus 1? Absolute value of 2 divided by 2. What is the absolute value of 2? The absolute value is just the distance from 0. So it's always positive. So negative 2, the absolute value of negative 2 would be 2. The absolute value of positive 2 is 2. So this would be 2 divided by 2, which is 1. Now, when does that actually come into a problem? When your entire graph is below the x-axis. When all your y values are negative, then you would say your amplitude's negative, but it can't be. So the absolute value, when you subtract them, will turn it to a positive number divided by 2, and you get an answer. Okay? So, what is the amplitude of this one? 1. What's the domain? Yeah. What was your question? Oh, I would wait for a second. What's the domain of this graph? Just because I drew from 0 to 2 pi, did it stop there? No, it's going to keep going this way, bouncing the same thing, and this way, bouncing the same thing. Yeah, so it's XCR in set notation. X such that X and L are the reals. In interval notation, negative infinity to infinity, round brackets because you can't equal. What is my y-intercept on the sine graph? 0, 0. What is the period of the sine graph? 2 pi or 360 degrees if it's in degrees. What is my range? What's the highest the y goes? And what's the lowest the y goes? So we're going to have to do the set of y values such that -1 is less than or equal to y is less than or equal to 1, y-e-r. If you're someone who still thinks I can't draw squiggly brackets, so I'm just not going to, you're going to get your domain and range wrong every single time, because that means the set of, that's what the squiggly brackets mean, the set of y values such that I would rather you have like kind of like a curvy 3s thing going on than nothing. They'll take the curvy thing and be like, ah, it's a curved bracket, and they'll count it. If you put no brackets, you're not giving the domain. Now, if it's equal to -1 in interval notation, we go -1, 1, square bracket. Now, where did the first x-intercept happen? At pi? Actually, where did the very first one happen? 0. Then at pi, then at 2 pi. So how often are they happening? Every pi. So we do general solution. General solution, you go theta equals, you start with your smallest one, which was 0. And then we add how much to get to the next one? Pi, n, and then we follow behind with n is an element of the integers, because we use 1, -1, 0, -0. I don't need to write the 0 though, so they'll probably write it as pi n nei. I want you to put sine theta into your calculator. When you go to press sine, slap your hand and be like, what mode do I need to be in? Well, what mode does this one actually have to be in? Radian, because the x-axis was in radians. So you're going to go sine x, mode radian, and then once you press the mode, if you want to help yourself, you can do this. If you're ever stuck and you're like, I don't know what to make a window, which I'll show you how to make this window, because this window's easy. But say you're stuck. You can go, after you press the mode, you have to press the mode first so your calculator knows you're in radian mode, right? You can go zoom 7. What is number 7? It's zoom trig, right? So if you press radian and then you press zoom trig, it'll make you a radian mode window. If you press degree, then you press zoom trig, it'll give you a degree window. Okay? So you can see it in front of your face, correct? If you want to see what matches ours, you're going to literally want to put in the window that we have. So go to your window. Bless you. What's my x minimum on this window? What's my x minimum? X minimum. 0. And what's my x maximum? 2 pi. So put x min at 0. Put x max of 2 pi. And what scale did it go up by? What's my first one? Pi divided by 6. That would be my x scale. It's what each tick is worth, right? And this tick's worth pi over 6 and 2 pi over 3 pi. So your x min is 0, your x max is 2 pi, your x scale is pi over 6. Your y min is -1, your y max is 1, and what am I going up by? 0.25. And then you should press graph, and it should match the same exactly what you got. Did it match? Perfect. Alexa threw her calculator. She's mad. She's like, didn't match. No, okay. Just kidding. So if it doesn't match, hers matched, I was joking. But if it doesn't match, what might have happened is your calculator might be in degree mode. Guys, paying attention? If it doesn't match, your calculator might be in degree mode. Okay? And you just made a radian window. That's not going to work. And we want a radian, so we go make a radian, change it to radian, and make a radian window. Right? Okay, you're going to flip over. What do you think's on the next side? Cos. So what are these all split up into? How many ticks are there to pi? How many ticks are there to pi? 6. So this would be 0, and then 1 pi over 6, then 2 pi over 6, which is pi over 3, then 3 pi over 6, which is pi over 2, then 4 pi over 6, which is 2 pi over 3, then 5 pi over 6, then 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, and then 12 pi over 6. Okay, so we're labeling our x-axis by pi's over 6. And then I just reduced the fractions. So it was 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, etc. Now we need to get... Did you just say he's getting paper towel? Is there not paper towel on the wall right there? That might be too. Okay, so we are going to do 0 this time, and then cos of 0, not cos of sine. What is cos of 0? 1. Because cos is all of the x values of the coordinates, correct? So my new coordinate for cos is 0 and 1. Then we're doing pi over 6. Cos of pi over 6 is? What is the x at pi over 6? Root 3 over 2. So it's 0.866. Should label these. So it's like here. Then we have pi over 3. What's cos of pi over 3? What is the x at pi over 3? 1/2 or 0.5. So this one actually starts at a maximum. And the other one started at 0, 0. And then pi over 2. Cos of pi over 2 is 0. You do the rest. So, remember that coses are x's. We agree? So in this quadrant, your x's are positive, then your x's are negative, then your x's are still negative, then your x's are positive. So remember, your x's are actually the y values, correct? Because you're doing cos of that. So this is positive in my first quadrant, negative in my second quadrant, negative in my third quadrant, positive in my fourth. That's why it's going below and back above. So if we do 2 pi over 3, cos of 2 pi over 3, I know it's an x value, I don't really care. It is a y value because when you plug in 2 pi over 3 in for cos, you get a y. It just happens to be an x on the unit circle. So cos of 2 pi over 3 is negative 0.5. Then we have 5 pi over 6. Cos of 5 pi over 6 equals negative root 3 over 2, which is negative 0.866. Then pi, cos at pi is negative 1. And then we have 7 pi over 6. Cos of 7 pi over 6 is negative root 3 over 2. And then 4 pi over 3. Cos of 4 pi over 3 is negative 0.5. And then we have 3 pi over 2. Cos of 3 pi over 2 is 0. And then it's going to go to half, 0.866, 0, or 1, I don't know, does that. So cos graphs, if we want to look at it in longer, It starts at 1, goes down to here, goes up to here, goes back up to here, and then what's it going to do? Just keep going. What's this going to do? Same thing, right? So from a max to a max is actually a period of a cos, right? And then it would do it again. So how long does this graph take to repeat itself? Here, down to min, back up to here, right? How long does that take? 2 pi. It's the same thing. Sine graphs and cosine graphs take 2 pi to repeat themselves, which happens to be the length of the unit circle. Correct? Because after the unit circle, what's going to happen? I'm going to start using the same y values again, aren't I? That means keep using the same y values, same y values, same y values. So, I know the period is 2 pi or 360 degrees. Okay? The amplitude is max. That's the value of max, which is 1, minus min, which is -1, divided by 2, which is 2 divided by 2, which is 1. The amplitude makes sense because you count down and count up. And they should meet at the same spot. What's the domain? XER, because it's going to keep going and going and going. X such that x and m are the reals. Or negative infinity to infinity. And what's the y-intercept? 0, 1 this time instead of 0, 0. Your range is still, in set notation, y such that -1 is less than or equal to y is less than or equal to 1, y-er. -1 to 1. Where does your first x-intercept stop happen at? Pi over 2, then at? How far apart is that? Yeah, 1 pi. So we're going to start at theta equals pi over 2, which is my first positive one. Then it happens every pi n nei. General solutions are 2 pi n nei because we're just doing coterminal angles, correct? But these happen every pi. I want to show you something cool. I want you to write that down. You're going to go to your calculator. In y1, you're going to put sine x. And in y2, you're going to put cos x.
Doesn't matter if you put the sine in 1, 2.
Nope. So on your calculator, you're going to get something like this for sine. Pretend those are the same height. So you're going to have something like that. Okay, if we actually extend this, it would look like that. If we extended this, it would look like that. So these graphs look the exact same, just shifted. Do you see that? Where did this max happen at on the sine graph? At pi over 2, didn't it? The blue being the sine x graph. It happened at pi over 2, which makes sense because at pi over 2, y is 1. Correct? So this maximum happens at pi over 2. But on the cos graph, the maximum happens at 0. Do we agree? How can I make the cos graph land on the sine graph? Translate it what? How far? Yeah, pi over 2 to the right. Do we agree? Okay, so in y1 put in sine x. In y1 put in sine x. In y2 I want cos x, but I want it to be the same spot as sine. So I want to take this green graph and I want to move it so that it actually matches the graph. How do I do that? You can go x. I want to move it to the right. So what am I going to do? minus, and how far am I moving it? Minus pi over 2. Now, if you have the calculators that don't have a color, please go over here and make this thicker. Why? Because sometimes people think it's drawing the same graph, when in reality it's drawing one graph and the other one off the screen, and you don't know. So we're saying that if I take the green graph and I move it pi over 2 to the right, I'm going to get sine. So once you put them in, press graph and see if it happens. So I can make the cos be the sine graph, correct? Can I make the sine be the cos graph? So if I make y1 be cos, how can I move sine to make it land on cos? Yeah, you're going to add pi over 2 because we need to move it to the left pi over 2. So try this one out. Did you get it to show up? So for today, that's what we're looking at. We're looking at the two graphs. That's it. For the rest of the day, I'm going to throw a proof up, see if you can do it. Throw a verification up, see if you can do it. Okay? So you need paper out to try. 2, you're not going to do number 2. We're just doing number 1 for now. So I want you to do, simplify the one on A. A, you're going to simplify. Oh, I have it frozen. 1 second. You're looking at nothing. Okay. A, you're going to simplify by proving it. So you're not going to put anything into it. This one has numbers. So what am I expecting you to do?
Yes.
By verifying. So your very first step, you're going to go to your unit circle and pull off values. Okay? This one, you're not going to put in any values. You're going to go to your formula sheet and try and simplify it to something. So try out A and B. The first one, I would make C. I would pick up my marker. Okay. I would make secant be 1 over cos theta times that by sine theta over 1 times that by cos theta over sine theta, which is cotan. And then we get our stacking fractions. Do I love stacking fractions? No. But if this is where you went, I'll just go there too. Sine theta over cos theta. And then cosecant is 1 over sine theta. So you can stack a fraction once, but you're going to have to not stack it in a second. So the cos and the cos cancel, the sine and the sine cancel, and I'm left with 1 in the top, and then the sine and the sine cancel, but I'm left with a fraction in the bottom. So I'm going to write it not stacked. So it's 1 divided by 1 over cos, which is actually 1 times cos over 1, cos theta over 1, which is just cos. This one we have tan 5 pi over 6 plus tan pi over 5, or tan pi over 3, 1 minus tan 5 pi over 6, tan pi over 3. Wow, I've seen that formula somewhere. Oh, it's the tan A plus B formula, isn't it? So you spot it because these are the same. So it's going to be tan A, which is 5 pi over 6, plus B, which is pi over 3, which gets me tan 5 pi over 6, plus, and times this by 2, times this by 2, 2 pi over 6, which equals tan 7 pi over 6, which is 3 over 3. Because every 30 or pi over 6 is root 3 over 3, is correct? And 7 pi over 6 is here. And what is tan here? Positive. If it would have been a 60, they would be root 3, not root 3 over 3. Okay. What's the next page I want to do? Okay, here. So here I want you to consider the identity secant theta minus tan theta and sine theta plus 1 equals cos theta. I want you to verify it, and then I want you to prove it algebraically. Don't worry about the calculator.